Hi, everybody. Welcome to Math with Ace, focusing on statistics today. We are going to be covering the shape of a distribution. When we are learning about univariate data, we typically describe a distribution using the shape, the center, and the spread, as well as any unusual features or outliers. So when we're talking about the center, we typically use the mean or the median. And we're talking about the spread, we'll typically use the IQR or the standard deviation. When we're talking about the shape, we need to talk about a couple of things. First, is the distribution symmetric? Is it skewed? Is it uniform? And how many modes are there? Is it unimodal? Is it bimodal? Is it multimodal? So we want to talk about what those things mean in the overall shape of the distribution, because the shape of the distribution will tell you how you should be describing the distribution. Consider a distribution that is symmetric. In a symmetric distribution, when we covered center, you realize that the mean and the median are really close together and should be roughly the same. And when you have a symmetric distribution, the average is a good representation of center. But when you have a skewed distribution, let's say you have scores of 100 on all of your tests, but you get 1, 0 because you were absent, the average is going to drop, but your middle is going to stay the same. So in that case, the median is a better measure of center. So what does it mean to be symmetric versus what does it mean to be skewed or uniform? Let's talk about uniform to begin with. When you think of a uniform is typically, when I think about it, it's something that people wear maybe to a job. It's consistent, it's the same. A uniform distribution is consistent or the same. It just means that all values are pretty much equally likely. So you might have a distribution that looks flat across the top. Or if you're doing, maybe different bars that are separated, you might get a little bit of kind of bars up and down, like this. Like maybe you have a bar here, and then you have one that's just a little bit above it. Something like that. Okay, that's what I mean. So in a uniform distribution, roughly all values are equally likely or present or frequent. If you see a distribution that's flat across the top or has all values that are pretty much roughly the same, we would call that uniform. There's not a mode in this case because all values would be the mode because they'd all be presented at the same time. Then we have what's called symmetric. A symmetric distribution is one where if you were to draw a line down the center of your distribution and fold your image in half, try that with a line. If you were to draw that line down the middle and fold it in half, the left-hand side and the right-hand side look the same roughly. So if my distribution looked like this, it's symmetric because the left-hand side and the right-hand side look roughly the same. Notice I'm using wiggle words like roughly or appear to be, because in order to be symmetric, it does not have to be identical. The left-hand side is identical to the right-hand side, but it can be roughly the same. Now, there's different ways to be symmetric. I could also be symmetric using, let's say, my pink graph here. Those are off to the side, but if you folded that, the left and the right-hand side would match up. The difference here is the number of modes. In the first picture, the black picture, there was one main peak. We would call that unimodal. Like unicycle, one wheel. For the two peaks, we would call that bimodal. Bi, like bicycle, two wheels. And a bimodal distribution has two main peaks with a valley in between. A lot of people might get confused if they're looking at a distribution that have two high peaks, and they would call that bimodal because I have two high bars. That is not bimodal. Bimodal is when your distribution has two main peaks with a valley in between. Anything that has more than two, we're just going to call multimodal. A distribution that is not symmetric or not uniform is going to be something we'll call skewed. And a skewed distribution is when most of the data live in one area and then outliers or unusual values pull some of the data to another side. So for instance, you might see something like this. I'm going to make it even more exaggerated. Okay. We would call this distribution skewed. Because notice, if I was to draw a line straight down the middle, the left-hand side and the right-hand side are not mirror images of each other. The left-hand side has much more data than the right-hand side does. But when we say skewed, are we skewed positive or negative? I don't like to say positive or negative. I typically will say skewed right or left. Your teacher might teach you differently. But we are skewed where the data does not live. We are skewed based on the unusual features, not the usual features. So most of the data is here, but the unusual data is to the right. So we are skewed to the right. So it's not skewed to where the data live, it's skewed to where the data don't live because it's the outliers that are skewing the data. They're the ones that are causing the issues. So I like to think about it as, if I'm at the top of this peak here, and I've got some skis, do I want to ski down the fun, nice hill here, or do I want to just drop off a cliff here? I want to ski down the one that's got a nice slope. That is the way that it is skewed. It is skewed to the right. It's skewed to the side that you would want to ski down. You could, play devil's advocate. I want to drop. Okay, fine. That's fine. Skewed to the left would then be if you were to reflect this and have most of the data to the right and not all of the data to the left. So something like this. This is skewed left. These are what you would see if you were to maybe smooth out a histogram. But what we're looking at here is if you were to look at a box plot, what would the box plot look like? A box plot here might look something like this. Okay, or something like this for some sort of approximation. Notice that those whiskers are very long. The long whiskers are where you're skewed. The longer whisker is to the right. This is skewed to the right. The longer whisker is to the left. This is skewed to the left. Both of these are unimodal. Okay, so we have one peak. So whenever we're describing shape, you want to talk about how many peaks there are. Is it unimodal? Is it bimodal? Is it multimodal? You cannot tell that from a box plot. You can only tell that from a histogram or a dot plot. So how many modes are there? And then is it skewed or is it symmetric or is it uniform? So be sure and consider those things when you are describing the shape of your distribution. Thanks for watching.